Merlin, thank you so much and really appreciate bringing your experience from across the pond, as they say. So really appreciate it.
You're very welcome. Yeah.
Thank you.
Thank you.
All the questions. I'm gonna leave the chat open for just a little bit in case people are gonna do a little bit of back and forth. But what I want to do now is thank Merlin, and we're gonna really turn to Angela Silva, who's now gonna start working us through, kind of give us an overview of the outline for our socioeconomic work. And then we're gonna dive into various panels and presentations. So Angela, I'm gonna turn it over to you.
Thank you, Pat. Thank you everyone for joining us today. Thanks Lane for throwing up these slides. Thanks for joining us for a full day of our socioeconomic discussions, and thank you, Merlin, for your remarks on the importance of understanding these socioeconomic effects, including the cumulative impacts. As we've been discussing throughout this workshop, it's crucial to learn from our UK and international colleagues in order to improve our understanding of the socioeconomic effects of fisheries and offshore wind, and most importantly, including commercial and recreational fishermen and industry in this process. And judging by the interest in the chat, I'd say there's definitely value in connecting more with Merlin on this. So my name's Angela Silva. I'm a social scientist on the wind team at the Northeast Fisheries Science Center. I'm relatively new to wind research, but I'm co-leading this section with Fiona Hogan at Rhoda, who will moderate this afternoon. So we have a number of topics that'll be addressed both in the plenary panel presentations, and I encourage everyone to participate in any breakout panels as well that you can. We've set up the panel presentations today for authors and other invited panelists to present their work and state of their knowledge, which will tie into our white paper. We're early on in the synthesis process, so we look to the audience today to further expand our knowledge both here in the plenary and the breakout groups to help us with our next step in this process, which includes continuing to synthesize the existing literature and of course identifying gaps, which as Merlin discussed, there are many socioeconomic gaps that we will work to make recommendations for future research. This screen here are there's a number of topics for socioeconomics that we would love to cover for the synthesis. We may, there's a lot. So in the interest of one single day, we may not discuss all of these, but we're gonna start we have about an hour, a half hour to an hour for each of these topics. And we'll start with fishery operation effects. I won't read through all the topics for each section, but I do want to note that if anybody has any comments on the topics that we plan to cover and would like to send us feedback, that would be great. Make sure we are not missing anything major in our work. That would be great. I can put my email in the chat or contact Rhoda as well. So we're going to start with the fisheries operational effects, and I will introduce, next slide, Lane, the panel. All right, so first we'll have Fred Matera from the Commercial Fisheries Research Foundation in the Northeast. Fred is a commercial fisherman with over 40 years experience and owns and operates the Northeast Safety Training Co. Then Tom Sproul, URI Environmental and Natural Resource Economics professor, will present his work on the state of navigation safety risk assessments for offshore wind. And Mike Conroy from the Pacific Coast Federation of Fishermen's Association brings commercial fishing experience and legal background to his virtual table, and he consulted for a number of groups operating off the West Coast, so he'll provide a West Coast perspective on wind and operational effects. And last but not least, Talia Tenbrink from the NOAA GARFO office will present her findings of operational effects and integrating social and ecological research on the impacts of offshore winds in North America. So I will turn the discussion over to you, Fred. Thank you.
All right, Fred, over to you. Fred, okay, great, there we go.
Stop.
Yep, you're good. And Fred, do you have slides, or are you just going to speak?
Yes, I have just a couple.
Okay, so we will stop sharing. Now you should be able to share your screen.
Okay.
Got it.
Thank you. Thank you. I appreciate this and welcome. And it's great to see a cross section of individuals, especially those from across the pond. They have a lot more experience, and it's great to share with them. I want to touch on a couple of subjects here. And I look at this as best practices and how this industry can get involved more in the science. Um, Radar interference. This has been an ongoing issue and a concern, especially for mariners here in the Rhode Island, Massachusetts area, because we have the first 5 turbines out by Block Island. And, numerous vessels obviously are steaming to and from the grounds, fishing in and around those turbines. And there isn't one that doesn't complain about radar interference. What does that mean? It's actually is clutter, it's double imaging, it's spoking on the radar. So, when you're having that, you start to wonder what happens when I get in the maze of, 100 or 80 or 50 of these. Will I really have eyes using my radar, which are necessary in foul weather and inclement weather or limited visibility? There is a proposed study, and that's with Vineyard Wind and the Coast Guard. That's been ongoing for a while. I am concerned because, the Coast Guard study through the MARISPA basically said that they didn't do anything for radar because they didn't have any studies to refer to. So I'm questioning and I'm hoping that, something realistic comes out of this. My understanding is now that it's been delayed till 2021. I can factor in the fact that, COVID has been a real issue here, but I still don't understand why this can't happen. Fishermen are going to sea day to day to day. So why can't we go out and conduct this survey? Conducting this survey out at Block Island site with 5 turbines and, Block Island just a little over 2 miles away. I think it'll be somewhat valid, but I question the fact that we're not in a maze of turbines. And that's what I think would be more realistic. So I'm concerned that with the methodology, I'm concerned the transparency, I'm concerned that we didn't have an industry scoping or working group working together on this. And if it did happen, then shame on me and a lot of others, because everyone I talk to isn't aware of all this. So it brings me to consider an alternative. I have brought this up with some of the individuals from the UK with Ørsted and begged them to conduct a study there off of the UK. Why the UK? Well, as we know, all the other EU countries that have wind farms do not allow fishing in and amongst those wind farms. Only the UK allows this. So, and, in and around the UK in the North Sea, there are wind farms with 20 to 30 turbines and some as many as 40 to 50 now. So to me, this is where we should be conducting a study. This fishing, we could use different size vessels, anything from 15 meters to 30 meters in length, low profile, high profile. The vessels could easily use conventional scanning radars. And there is this new pulse compression radar, which I've read an awful lot of material. I've spoken to several of electronics installers that have put these units on high-end, high-valued yachts that have worked extremely well on cleaning up clutter and everything else. So I would like to see that happen. I think it would, we could simulate pathways through, in, and around the wind farms there with a multitude of turbines. But I certainly want this staffed with some radar expert from the US and a minimum of 2 fishing captains from the US. I think it would be more conclusive. I think it'd be realistic. And I think they would be good observers and spokespersons after they have experienced such a study to come back and, get buy-in from the industry and all mariners. So that's my concern and appeal here to radars. Next, I'd like to talk about insurance and insurance risk. I do have a background in insurance. I've been, actually, I was vice president of the Point Club for 14 years and 21 years as president of the Point Club. It's a mutual insurance group. A lot of Mariners are aware of it. We're here throughout the Northeast, and I've been a director for a UK underwriter, which is Sunderland Marine, for 21 years. They were the second largest marine global insurer. So I've had an awful lot of experience with insurance and with marine insurance. You know, marine insurance is managing and assessing risk, and you have, for fishing vessels, two types of coverage. You have hull and machinery, and what does that entail? It's damage to the hull or any types of machinery. So if you have damage to the hull through maybe a hole in the hull, a crack in the hull, electrolysis that caused this, you have a snap shaft, you have damage to a wheel, if you ground the vessel, all of those things come under that hull coverage. And machinery is any of your main engines, your gen sets, equipment on the vessel, winches, etc. All of those things are covered under that hull and machinery. You know, hull and machinery, those things are covered, and they're actually very limited in short term. You know, you basically have damage to a vessel, you go get it assessed through a surveyor and find someone, either a shipyard or someone, to give you a quote, and that's it. You know, he tells you it's going to take 3 months to fix this, and it's going to cost you $150,000. And essentially, there's very little difference in that. Now, when we talk about protection indemnity, that covers liabilities, injuries, loss of life, and any property damage. So if someone was injured, if someone lost their life, if you hit another vessel, if you hit a turbine out there, if you hit a buoy, if you hit a dock or anything else and did damage, that's where this protection and indemnity comes from. Injuries, loss of life, these are long-term claims. These can last anywhere from 3 to 7 to 8 years. A lot of it here in the US is due to the litigious nature of our, society here. You can get tied up in the courts for a good 5 to 7 years. The insurer will put aside $500,000, for a loss of life, and 7 years later, the final claim is $2 million or $1.5 million. It's very difficult. It's high value. And, what's surprising, around the world, hull and machinery for other countries, that coverage is higher than their protection and indemnity. Our cost for hull and machinery and protection and indemnity, our P&I coverage is almost twice what our hull and machinery is. And that's just due to the nature of the United States and North America. Risk factors, this is what they look at in order to manage and assess what values are and what premiums should be. And that's based on collisions, elisions, property damage, personal injury, loss of life. And now we have search and rescue that could be compromised when we build out these turbines and wind developments. So,
Fred, I don't know if you can wrap up just because we're a little bit over time. Sorry about that.
Okay. Contributing factors, a close proximity of turbines, 1,410 contiguous square miles of turbines, the world's largest, radar problems, navigation problems, lack of transit lanes, weather, fatigue, and sleep deprivation. In the North Sea and in it's unique. Only the UK can fish through those wind farms. And most of those fishermen refrain from engaging in those areas. And the one thing that they do have, and you heard Malcolm talk about it and Merlin, is that they do have gear damage that's snagging on the cables. I'll give you one policy exclusion, and this is what could happen. If we start to have a myriad and a large number of hull damages or loss of lives or injuries or protection indemnity claims. This is what happened in Woods Hole. Woods Hole is a very difficult place to traverse through. It's brutal tides, and many vessels have run aground because of the shoal water and the tides around there. Well, back about 8 years ago, we had enough claims through Sunderland for vessels transiting through Woods Hole that they put an exclusion in their policies that you were exempt of having coverage if you went through Woods Hole. And this is the same thing that could happen on these grounds. So excessive damage contribute to higher premiums, and also I'll leave it at that. And thank you.
God, Fred, thank you so much. And if you would unshare your screen too for the next presenter. Fred, thanks so much. Okay, so Angela, back to you.
Thanks, Fred. Just so everyone's aware, there is a breakout session too on this topic, so we can continue the conversation there. I will turn it over to Tom.
10 minutes. 10 minutes. Tom's going to be.
Okay, here I'm gonna share my screen. I have slides here. Everybody see this okay?
Yep, looks good.
Looks good.
Okay. All right. So what I want to talk to you guys about a little bit today is the state of what's going on with navigation safety risk assessments, and in particular, taking a kind of close look at what are developers doing in their, excuse me, in their construction operation plans, their COPs, and some suggestions I have to make things better. So this is a project that is funded out of the NSF Science Center for Marine Fisheries, SEMFIS, out of the University of Southern Mississippi. And we've been working on this for about a year, and we've identified a number of important challenges for how to move the science forward. So I'm going to give you a brief sort of US-centric history of these NSRAs. I want to give you a sense of how economists tend to think about risk, and in particular focusing on navigation safety risk to fishing vessels and other vessels. And then I want to give you a little proposal of how I think we should be doing things better. So I'm going to focus today on better modeling of accident probabilities. And then I want to sort of encourage everyone to think about the fact that we really need to look at what are the actual costs. What does it mean, navigation safety risks? How do we turn those into dollars and cents in the same way we evaluate other challenges? In economics, and looking at assessments of environmental policy, for example, we look at loss of life. In this case, there's also loss of property and search and rescue costs. And finally, the sort of end goal is actually to say things like, how will vessels adapt? So we can look at the trade-offs that they face, and we want to see how can we predict what vessels will do in terms of navigating through the wind energy area, for example, when it's fully built out. So this is, and forgive me to my, to all of our international visitors, this is a US-centric review of offshore wind navigation safety risk assessments. But if we look back at the ones in the US, we have Deep Waters one for the Block Island Wind Farm prepared in 2012, and we have Vineyard Wind's COP more recently in 2018. Both of these bring up elision risk to turbine structures, but they don't actually evaluate risks to the vessels or to the vessel occupants. So there's actually, from my perspective anyway, a somewhat alarming description in the Vineyard Wind COP in which they discussed scenarios in which a turbine could fold over and fall down when a vessel strikes it, but there's no mention of what happens to the vessel or occupants when the turbine falls on them. So I think we have certainly a need for a little bit more thorough analysis here. And one of the biggest problems in these early efforts is that they don't actually model the risks. They basically do a visual inspection of vessel traffic and leave it at that. If any of you guys are wondering about a point of vocabulary, allision is a vessel running aground or striking a fixed object like a wind turbine. Collision is when two vessels hit each other. Okay, so then we have more recently the Ørsted COP for the South Fork Wind Farm, and they actually do some formal risk modeling, but it's somewhat limited. They're using these sort of geometric risk models, which I'll show you, that have been around for about 40, 50 years now, but they are unsatisfying in terms of the type of modeling that we need to do. Then more recently, last November, we had the grid proposal that was put together by the developers. Baird was the consultant that did the risk assessment. They also did no formal modeling, and they incorporated harbor guidelines for some reason instead of open sea guidelines in their assessment. We then had the Maripar study in May of this year. We don't actually have time in this discussion for me to get into all of my problems with the Maripar study, but suffice to say, they didn't really do a very rigorous analysis of what the developers had proposed. Not included in here, though, is the supplemental EIS released by BOEM earlier this year, where they don't highlight it as a key finding, but they actually do point out that they're expecting, and this is a quote, overall cumulative impacts on navigation and vessel traffic would be major, due primarily to the increased loss of life due to maritime incidents. So there is at least some concern about it, but unfortunately we don't have much in the way of quantification of these effects. Okay, so as an economist, the way I think about measuring risk is I look at sort of all potential outcomes that might happen and what are the payoffs of those. Payoffs in the case of vessel accidents include things like loss of life. So Fred Matera talked about loss of life in an insurance context, which often means either a wrongful death lawsuit or else a workers' compensation claim. So for example, in New York State, they have a $2 million work comp death benefit, but it varies dramatically over states. In terms of working under NEPA, most federal agencies use values between $6 and $7 million for a statistical human life being saved. Okay, once we've identified sort of outcomes and payoffs, we want to estimate the probability of each outcome. In the case of vessel accidents, we're talking about something called a drift strike following a mechanical failure, or a powered strike due to some form of navigation error. So this can include human error, or it can include failure of navigation systems due to inclement weather, etc. Okay, and then what we do as economists is we apply a cost-benefit analysis where we weigh all the costs and benefits together. We can weigh bad states more or less than good states, but I'm not going to get into any of that here. And this meta question that I identified is, how do vessels respond? And this is ultimately where we're going with this grant proposal, which is we want to look at the trade-offs that vessels face. They have operating costs, fuel, maintenance, crew, opportunity cost of time, for example, lost fishing time, and they have to trade that off against the cost of risk. Okay, the probability of an accident times the loss they incur with that accident. So going faster or slower is a trade-off, which route they take is a trade-off, and accurate modeling of these means we have to get the component pieces right. So I want to show you just a taste of why I think we can improve the probability modeling here. We have sort of baseline probabilities of mechanical failure or of human inattention, navigation error. Those are subject to weather, but we still have to deal with the probabilities that once a vessel is adrift or off track, that it actually hits something. So this Ørsted COP is the only one that really does explicit modeling. But what we've identified is that their modeling doesn't really handle risks well at close distances. So it is a well-established approach. Essentially what they do is they look at a vessel at a point in time, they draw a circle around that vessel that intersects with the wind turbine. They assume the vessel is going to exit the circle exactly one time, and then the probability is based on essentially the direction. So let me show you a picture of this so you can see it. And sorry if this is a little bit blurry. Essentially, you've got the vessel here in the middle. They identify ranks of turbines that are around it, and then they use the vessel length and the turbine structure width to look at what is the probability in terms of what percentage of this circle is taken up by a turbine that they're going to hit. Okay, so what I'm proposing that we do instead is a more bottom-up systems approach where we actually make a statistical model of a drifting vessel. This is fairly common in the search and rescue literature. So you assume, for example, that at every time increment you have a bell curve of movements in the latitude and longitude direction. This can increase dramatically with wind and currents, depending on how far you are offshore. Which one is a bigger factor tends to matter. My understanding is that in the area of the Massachusetts and Rhode Island wind energy area, that wind is the larger effect, but this is definitely subject to specific location modeling. And then we also make an estimate of how long it takes for a vessel to either be rescued or recover from their state of being adrift due to a mechanical failure. So I've chosen here for this simple case, average waiting times of 1 to 4 hours. So what we get with this bottom-up approach is that if we're looking at a vessel that's half a nautical mile away from a turbine, the models actually agree, as we get about a 0.3% chance of an collision with the turbine, whether you use the geometric model or whether you use this bottom-up model that I'm proposing. The difference is that the bottom-up model handles the closer distances much better because, of course, if a vessel is moving around randomly in the ocean, there's no requirement that it can't, bob around in relationship to the area of that circle where the turbine is found. This bottom-up model is also easy to extend. We can address the powered strike risk in a consistent way. Right now, the way they're dealing with powered strikes is they actually just take a half circle in the direction they're pointing, which fails to account for all kinds of things like the actual path of the vessel as it moves. And probably the most important thing.
Tom, about a minute left if you can.
Okay. Probably about the most important thing is that we can estimate the cumulative risk. So if you look at Ørsted, they are doing this model for the South Fork Wind Farm, which is like 16 platforms. If we're talking about 1,000 of them in the wind energy area, we really need to do cumulative risk assessment, and it's simply not possible with this half circle model that they propose for the powered strikes. So this is a comparison of the models. This blue line here at the bottom is the geometric model, and this red one here is the 4-hour average recovery time one that I said matches. So you can see they all tend to agree around half a mile, but depending on how rapidly you expect a vessel to recover on average, when you start getting under a 1/4 mile, these tend to start disagreeing with one another. And so this is actually really important because one of the key things I think that inflamed a lot of people that are concerned about navigation safety risk in terms of the MARPAR study and the developer proposal is that you have this idea that these diagonal corridors are safe in this giant grid. And in particular, they're suggesting that it doesn't matter that vessels are proposed to take 60-mile trips through a corridor that's only 0.7 nautical miles wide, where they're suggesting that two-way passage is possible even with 400-foot vessels in the wind energy area. So I'm hoping that we can move towards evaluating these claims more rigorously and ultimately moving towards a system of standards where we can have clear reporting requirements for the developers to actually assess these things in a systematic way and get better information for policymakers, including for BOEM in their environmental impact assessment.
Great, Tom. Thank you very much. Appreciate it. All right, Angela, who are we on to next?
Oops, sorry, I was on mute. We will move on to Mike next, who will talk about some other operational effects from a West Coast perspective.
Right. Mike, thank you.
Hi, good morning. Just making sure you can hear me.
Yep, sound great.
Okay. Greetings from the West Coast. I took a little bit of a different approach to this and looked more at the, how this is actually going to impact fishing operations. Very much appreciate Merlin's comments and his warning that he offered during his keynote address. We here on the East Coast, we're about 1 to 3 years behind you all on the East Coast. My fellow West Coasters will attest that there's been quite a few of us that have been screaming pretty loudly about offshore wind over the course of the last year and a half, and our screams are beginning to be heard. I myself am very encouraged by the number of West Coast folks that I have seen that have registered for this workshop and have attended. So I very much appreciate that. And I also very much appreciate the points that Fred made earlier in this session with regards to impacts to radar and impacts to insurance. I think those are both really important matters that deserve further understanding and the like. As you'll see, I break down my discussion here is about with regards to what we know about impacts to fishing operations and then areas that what we need to know. In terms of what we do know, the draft supplemental EIS that was announced, that was published in June for the Vineyard Wind, acknowledges that there will be major impacts on the commercial fishing industry from offshore wind. So we know this. BOEM has promised to engage with commercial and recreational fishermen to ensure a full understanding of potential impacts. To the extent that BOEM will actually reach out and select and seek input from the fishing community for project siting, best management practices, research, and monitoring, we applaud that. And hopefully the BOEM on the West Coast will increase efforts along those lines, as was talked about yesterday, and I'm sure will be talked about throughout the rest of this workshop. I will note that the final EIS on the Vineyard Wind project is expected for the end of the year, and hopefully that'll add some additional clarity. With regard to de facto closures for certain gear types, I think Tom touched on this a little bit when he was discussing operationally in between within the arrays. Clearly, there are some gear types that will be better able to coexist with wind farms than others. For example, I think a rod and reel fisherman or woman will fare much better operationally than a trawler or a purse seine fisherman. With regards to operating in and around these wind farms, we assume that there will be safety zones established in and around the farm in general and each turbine specifically. And we further assume that the extent to which these safety zones may differ for floating versus fixed wind facilities. With regard to the differentiation between fixed and floating, on the West Coast, the facilities that are planned further offshore, 10 to 25 miles offshore, and in deeper water. I believe in water up to upwards of 500 fathoms. Each project which has been proposed, at least those of which we are aware, will use floating technology. These will be tied together via subsurface inter-array cables, which will be roughly 55 fathoms below the sea surface. And then these will in turn then be anchored, tethered to the seafloor. Why this is also an unknown is because we don't know how far apart these things will end up being, the facilities themselves. We don't know what impacts will be to the fisheries that operate beneath that depth where the inter-array cables will be. We don't know the scope on the anchors, the tethers that will be, so we don't know how much of an operational closure will be around each floating facility. We are also concerned about the potential impacts to fishery operations well away from the farm itself. For instance, buried cables, could that impact bottom contact gear types? The energy has to be transmitted from 10 to 25 miles offshore all the way into the shoreside receiving location by subsurface cables. We've been told that they're going to be buried or they will be placed under the seafloor with a cement cap. Will there be anchoring restrictions around these areas? For example, there are some high-tech cables that are buried below the sea surface at San Clemente Island, and there's an anchor safety zone where vessels aren't allowed to anchor there. So we're curious as to whether or not where these cables will be located, will we be able to anchor in and around those areas? I think Malcolm mentioned this right before this panel started. Other unknowns that exist would be availability to the fishery. For example, will the floating offshore infrastructure be the functional equivalent to a fish aggregating device so that it takes fish away from a fishery? The example that we used was if these are key attractants for forage fish, then will fishermen targeting albacore, a highly migratory species off the West Coast, be unable to access those fish because those fish will be ending up in and around the infrastructure for that. Another one, impacts to long-running surveys. It's important, couple important fisheries here off the West Coast, groundfish and coastal pelagic. Catch limits are based on modeled biomass. Biomass in turn then are based on long-running surveys, and some of these surveys have a trawl component. To the extent the survey transects lines will have to be moved, what impacts will there be on the biomass estimates? And then in turn, what will be the impacts to quotas? With regard to infrastructure impacts, what will noise generated by the floating facilities differ from that generated by the fixed facilities? There is a pronounced fear of, especially these large facilities that could be located off of Humboldt, toppling over. Weather buoys don't fare well up in that area because the seas are very rough, wind with large swells, so we're concerned about them toppling over. To what extent will portside infrastructure serving the commercial fishing industry be repurposed for use by offshore wind? We need to look at when we're studying the socioeconomic impacts of this, need to look beyond ex-vessel revenues and consider the downstream impacts as well. Right now, there's a very limited amount of space available in ports and harbors where the California coral areas are located. Morro Bay, Port San Luis, and Humboldt, they're all small commercial fishing harbors. Expansion within these harbors is unlikely. And then as more and more vessels serving wind farms move in, will commercial fishing be pushed out? Will folks stop delivering to these ports? As folks stop delivering to these ports, what happens to the offloading facilities, the ice houses, the fishmongers, the fuel docks, the local mechanics? It's all intertwined. So I think there's a lot that remains unknown, a lot remains to be seen. I would like to think that as we catch up to you all on the East Coast, time will be spent looking at that and coming to terms with that so that we can make more informed decisions with regards to the siting decisions and operational aspects so that impacts to fishing can be minimized to the extent practical. And I will stop before the shark opens its mouth. Thanks.
Thank you. I really appreciate that. And just to know, we are going to probably have a limited time for questions in this section, but the breakout groups right after lunch are going to cover a lot of these. We've got one on actually sharing the ports, to Mike's last point. We've got a whole one on actually floating technology to kind of dive into some of these questions Mike raised more, and to some of the points that that was raised, both Fred about radar and Tom about navigation and navigation risk assessment are going to be covering it, safety at sea. So we've got lots of breakout groups to dive into these more. Okay, and with that, I think Angela's Talia up next.
Yep. Thank you, Mike. And we'll switch it over to Talia.
Excellent.
Thanks. So I'll be talking today about a study we published in 2018 on perceptions of commercial and recreational fishers on the impact of the Block Island Wind Farm, and then challenges and synergies for integrating that research with the biological research conducted around the Block Island Wind Farm. And this was conducted when I was at URI, and my advisor, Dr. Tracy Dalton, and Julia Livermore from Rhode Island Department of Environmental Management. So we conducted an innovative interdisciplinary study. We interviewed 25 fishermen using semi-structured interviews in the summer and fall of 2017. So we gathered perceptions of changes in the ecology of the area during, before, and after, and also how fishers' behavior in the area changed. And so some of the themes that we've been talking about this morning did come up in those interviews, and I will talk about them in the next. So for recreational fishermen, the Block Island Wind Farm became a destination for fishing and a reference for good fishing. So people would gather there, say, let's all go fish at the wind farm. Some recreational fishermen and a few commercial fishermen felt that there was more mussel growth and fish attraction around the turbines, and their explanation for this was that the structure created a deep vertical ecosystem, and that was seen as rationale for additional fish. Spearfishing was also seen more in the area, with it being a target for spearfishing more offshore species, and also a novel experience for beginners. There are also several perceived negative impacts. So navigational hazards were talked about a lot. One fisherman actually invested in a new radar system and moved further offshore because of this. And so that kind of talks into the crowding or displacement. So when they were not able to fish in that area, that meant that they had potential conflict with other commercial fishermen further offshore. Several were concerned about running into the turbines because of fog or exhaustion. And the influx of recreational fishermen into the area meant the displacement of the commercial fishermen that were in that area that lost gear because their gill nets would get tangled in the lines of the recreational fishermen. There are also several effects during construction, with murky water quality and sound and vibrational pounding during the 3 weeks of drilling. So those were seen by spear fishermen on the island. So there were some impacts that could be seen as either positive or negative. So the novel audiovisual kinetic experience, or seeing it as an eyesore out there versus something that's really cool. And then others felt that there were no strong positive or negative impacts. So as someone talked about the artificial reef effect, this wasn't necessarily seen as a positive impact or a negative impact. Some felt that the Block Island Wind Farm was too small to actually have an impact on the fisheries, and that the additional structure didn't affect anything because there was already a lot of structure around Block Island, and that any changes in the area were due to the natural variability of the fish stocks. So in summary, the Block Island Wind Farm did have an impact on fishing and fishing behavior. Perceived impacts were positive, negative, long-term, and short-term. And commercial fishermen in the area in general had more negative perceptions of the impacts than recreational fishermen. So these results can be used to assess the impacts of future offshore wind farms, and the citation is below. So we tried to really use this and integrate it with the ecological data. So it was, as a collaborative study, the biological component was the ecological studies collected by the Deepwater Wind company through the consulting firm Inspire Environmental, and provided to the Rhode Island Department of Environmental Management. And you can see on this map where they conducted their monthly demersal fish trawl survey using otter trawls and a ventless lobster survey, starting 2 years prior to the construction period and ending 2 years after on a monthly basis. There are several challenges in integrating this data. First of all, the social science data was qualitative, while the natural science data was quantitative. So the qualitative data was open-ended narrative interviews. So these are great for capturing unanticipated phenomena, kind of seeing things on a larger level. This is why it's important to have dialogue with fishermen. However, the quantitative research was more useful for testing hypotheses against the samples. So you could really look at changes in those specific transects over time. So combining these inputs can provide a more complete picture of changes to the whole system. However, they can't easily be input into each other. So another challenge, which I'm sure fishermen see when they talk to scientists, is the differences in placement and timing. So the fishermen's observations were not confined to highly specific areas like the sampling sites used in the trawl survey. The fishermen chose which area to use and which species to target. They didn't have a specific amount of distance or placement away from the turbines that they had seen their observations. There was also differences in timing. The fishermen were drawing on a longer term continuous data series within which to look for patterns and anomalies. So the trawl survey was just to collect what was there at that time of day and that time during the month, whereas the fishermen had a wider view of the area. So in order to compare the two data sets, we would have benefited from additional ecological study sites and a greater sampling frequency. The final challenge is the species that each group focused on. So the fishermen were targeting for catch, and those divers viewed the things that the divers viewed around the base of the turbines. The ecologists focused on a broader suite of species and specifically more benthic species. Therefore, certain findings could not be validated across the different components. For example, fishermen noted that they saw mahi around the turbines, but the biological component did not corroborate this finding since the trawl survey did not target pelagic fish such as mahi. It was the same with cod and sea bass. More cod was seen in the area. However, that seemed to be due to temperature based on other data that Julia had access to. And the sea bass seemed to decrease in the area during construction and increase in the area after. Again, we found no scientific biological rationale or notice of this, but the biological studies were not designed to capture that. So that's kind of something to think about when you're designing these type of studies. The social science component found perceptions of an artificial reef effect, and while the trawl survey is not a common method for targeting blue mussels, they did see an uptick of blue mussels in the areas around the wind farm following wind farm construction. And you can see that they're pretty far away from, they're not all right next to the turbines. And the final challenge was framing. So the social science data was designed to supplement the biological research. However, because the fishermen focused on talking about their perceptions of biological impacts, there were other impacts that were not captured. So they were open-ended interviews, so fishermen were able to talk about what they cared about. However, many areas of social impact analysis, such as livelihood, governance, participation of fishermen in the planning process, those were not captured. So future studies are needed. So finally, what are the benefits or synergies? Well, the alignment of goals aided the study design, and then it also helped direct specific analyses. So fishermen could focus more deeply on topics that the biologists could focus more deeply on topics the fishermen recommended they look into. It also built relationships that could be leveraged for larger projects. And it, in the end, demonstrates why social science studies are important, to have a broader view than more specific studies. So in relationship to the breakout session yesterday, you can see that we need input from the community in designing the survey and then also in analyzing the survey. So it's really necessary to involve fishermen at the beginning and at the end of these scientific studies in order to find and create useful data. So finally, socio-ecological research can be improved by using synergies such as aligning goals to direct specific analyses and directing the research designs, as Rhoda is doing, and then addressing challenges such as designing complementary or replication of research within the research goals. So really drilling in to look at what exactly you want to find. And this is a publicly available paper, below here. And I'd love to open up for questions, and thank you for your thoughts.
Terrific, thank you all. So we're running just a little bit short of time, so I'm going to unfortunately probably truncate a few things, but I want to do one thing. I want to turn to Tom. I want to just note there's a number of recreational fishermen participating as well as commercial fishermen. So we've got Mike, Tony, Dave, Willie, Adam, and probably others, and we want to make sure that we think about recreational fishing impacts, good and bad, as well during this, and certainly in our breakouts. I want to note that. So Tom, to that question, when you look at kind of navigational risk and you think about pelagic fishing and rec fishing, particularly with rod and reel, is there any kind of assessment of that risk within these arrays that would be part of a navigation sort of review?
Patrick, the answer is yes, that would be ideal, but it's super difficult. And so one of the challenges is that, for example, with somewhere like Block Island, you have tons of recreational fishing activity. And so to possibly model the amount of vessel interactions, if you have commercial and recreational fishing going on at the same time, it's just a difficult problem. One of the challenges, so I have some other work on both in this grant and other ones where we're looking at sort of micro level vessel tracking data using the AIS, where we have 1 minute pings of vessel positions to try to model their movements. But the problem is that's only for larger vessels that are 65 feet plus. So with the smaller vessels, the biggest challenge is that virtually nobody actually has data where we can watch vessel movements and observe what's happening. So it gets very speculative very quickly when we start adding in lots of different vessels with unknown behaviors. So yes, it's very important, and yes, it's a big risk, but if you want a number for how big, I'm not the guy to give you that one at this time.
Right, no problem. And one other question for you, Tom, and I have one last one for Talia. And Tom, I think one of the questions that came up as you were presenting was asking about when you do these navigation risk assessments, how do you figure in all of the additional traffic that might be going on in the array just for maintenance, whether it's during construction or then later on operations and maintenance? Do you figure that into the nav risk study as well?
So in the specific study, the fishermen were compensated through a different kind of space for time lost at sea during the construction. So the area was the fishermen were not allowed to go in that area during construction, and they were compensated for their time based on their historic catches in that area. However, there was some miscommunication, and so they did lose, I think, a week or two, and then they discussed it with the developer later to try to get money back for that.
Great, thank you. And Tom, specifically just kind of a generic risk assessment, navigation risk assessment, do you account for vessel traffic due to kind of the wind farm itself?
So it is known, actually. There have been, I think, at least 1 or 2 accidents recently involving collisions between offshore service vessels and other vessels passing through wind farms in Europe in the last couple years. So it's a known source of risk, and something that needs to be addressed. But again, it's a difficult problem to solve. If you can look at the level of modeling that's being done, basically most of these assessments are just saying things like, we have X guideline and we obey the guideline or not. And they're not even actually trying to address the probabilities. And then in the case of Ørsted, where they actually tried, they have a very primitive model, and it doesn't really allow them to actually assess these micro level details of individual vessel interactions.
Great, thank you. I'm going to unmute Tony and let him have the final question before we do take a break. So Tony, who's a representative of recreational fishermen, over to you. And I think I've got you unmuted. See, and Tony, there you go. Tony, unmute yourself.
There we go. Thank you. Patrick, your question to Tom dealt with the interaction of the recreational vessels in the wind farm area. And he said, well, there's really no work that's been done yet. I suggest that perhaps the way it could be looked at is recreational fishermen will see the wind farm areas as a form of an artificial reef. That's what's going to bring them there. They're going to see it as an artificial reef. So if you want to look at interactions of recreational vessels, perhaps the best way to look at it is look at the current artificial reefs that exist off of Long Island. There are a number of artificial reefs that exist, and you may want to look at the interactions the recreational vessels have on those artificial reefs, because there'll be very little difference. So a wind turbine field is going to be an artificial reef as far as they're concerned. So whether it be an artificial reef that is totally submerged and not visible to the surface, or one that is visible because of the foundations, I think you'll see the recreational vessels interacting the same way. Thank you.
Great. Okay, good. Thank you. I'm just going to check the messages. There's some good back and forth in some of the messages. I'll just kind of note. And I think I note that I think what Sarah put in the Minty and also in the chat is just, I understand that people are really excited to engage, and we are constrained by time to do so. And I know, one, that's frustrating. So So we're trying to provide some accommodation as we go today. And I also note if people can participate in the breakout groups, they're much richer and much more robust in terms of full engagement for everyone. So encourage us to do that. And we're going to have one right after lunch. So we're going to break the breakout groups up a little bit more than yesterday, hopefully to make that feel more engaged. So with that, we're running about 10 behind. I want to thank the panelists very, very much for the great presentations, information, a lot of food for thought for the breakout groups, which are very directly tied to these ideas and issues, from floating to ports, to sort of radar, to sort of navigation safety. So look forward to that. We're going to take, I think we're going to go ahead and take a 10-minute break just to give people that, or 8 to be exact. So at 10 after the hour, we're going to start up on economic effects and go through that to lunch roughly, when we'll take a break for lunch. So again, if people could return at 10 after the hour, 10 after 11 East Coast time, we will start up again on the next piece. And Angela, thanks a lot for your section lead and moderation. Appreciate it. Thank you all. We'll be back in 8.